Welcome to this video on adding and subtracting radicals. So, I want you to have these 3 steps kind of in mind as we attack each of these problems. And if you get stuck, just go back and repeat to yourself, did I do each of these steps? All right. First, we need to simplify all radicals. Okay, that's what we learned how to do last time. So that'll continue happening. But that's the first step. The second step, we're going to identify radicals that have the same index. Well, all of ours will have the same index. It's going to be a 2. And they'll have the same radicand, which means the number underneath the radical will be the same. Only these can be combined because only those are like terms. And then for the common radicals, you add or subtract the coefficient or the number in front and keep the common radical. So let me show you what I mean. We could have 3 square root of 5 plus 5 square root of 5. Okay, simplify all radicals. 5 is already as simple as it's going to go, so we don't have to do anything there. Identify the radicals with the same index. Well, these are both square roots and the same radicand. They have the same number underneath. So far, so good. Only these can be combined. Okay. For the common radicals, add or subtract the coefficients, the number in front. Add or subtract the coefficients, so this is 3 plus 5. So 3 plus 5 is 8. And then keep the common radical. It is not going to change. It stays whatever it was. It's very similar to when we were combining like terms with 3x plus 5x would equal 8x. We kept the x the same. The only thing that changed was we added the coefficients in front of it. So our radicals are going to be very, very similar to that. So let's take a look at our example. We just said a 5 will not break down any further. So we know this is not going to break down any further than it already is. Okay, so I'm just going to bring it down. Minus 2 square root 5. Now let's take a look at this first one to see if anything can happen with this. Before I get started, I know there's a number in front, so I'm going to write negative 2 in front, and anything that comes out is going to multiply to the number that's already there. Sound familiar? Just like we were doing before. 20. There's a couple different ways to break this down. The first thing that jumped into my head was 4 times 5. Okay, so we rewrote the 20. 5 will not break down any further, but the 4 will break down to a 2 times 2. Okay. Now, nothing else will break down any further. I have a pair of 2's, which means a 2 will come out and multiply to what was already there. And this 5 has no partner. Remember, if there's no partner, they go back underneath the radical. So what do we get? We have negative 2 times 2, so we have negative 4 square root 5, and then we have minus 2 square root 5. Our radicals are exactly the same. Look at their coefficients. Negative 4 minus 2 more equals negative 6, and then keep the radical and radicand as it was, negative 6 square root 5. All right, let's try a couple of these. Number 1, let's start off easier. Notice they have the same radical and same radicand. 6 would break down to 2 times 3, but there's no pairs, so no, there's no simplifying that can happen here. The radicals and radicands are the same, so we just have to say 3 minus 2. Well, 3 minus 2 is 1. I'm going to write the 1, you don't have to. And then you keep the radical exactly the same as you do the radicand. All right, let's try 2. 2 is just like number 1. Simplify the radicals. Well, 5 is already simple, nothing we can do. We have the same index and the same radicand, so that means we are going to add or subtract the coefficient. So we have 2 plus 2, which is 4, and then keep the radical and the radicand exactly the same. Good. Now, let's make it a little bit harder, because this is more like what you're going to experience. First step, simplify the radicals. 7 does not simplify. So 10 root 7 is going to stay the same. Okay, let's see if the 63 will break down. So I'm going to take this plus 2. I'm going to bring it down, plus 2, and whatever comes out is going to multiply to that. Okay, 63. Right off the top of my head, I think 9 times 7. So I rewrote the 63, so I'm going to cross off 63. 7 does not break it down again, but 9 is 3 times 3. So all right, I see I have a pair of 3's. So the 3 is going to come out and multiply to that 2. And I have this 7 here who is alone, who's going to remain underneath the radical. So I have 10 square root 7. I have 2 times 3, which is 6 square root 7. Radicals and radicands are exactly the same. 10 plus 6 is 16. And keep the radical the same. Square root 7. All right. Hopefully we're starting to get the hang of this. Let's try it again. First step, simplify all radicals. So 15 would be 3 times 5. It's not going to break down any further. So I'm just going to leave it the square root of 15. Then I have this minus 6. I'm going to bring it down. And whatever comes out from under the radical next to it multiplies to it. 60, I think 6 times 10. So I rewrote the 60. 6 is 2 times 3, and 10 is 2 times 5. I have a pair of 2's. You see them right here. So I'm going to bring a 2 out, but then I have a 3 and a 5 that go back underneath to multiply together. Okay? So I've got the square root of 15. I have negative 6 times 2 minus 12 square root 15. I have the same radicands and radicals. Remember, there's a 1 here, so I have 1 minus 12 is negative 11, and then keep the radical the same, square root 15. All right, let's flip this over and try a little bit longer one. Take a look at number 14. So this has 3 terms that we're adding together and subtracting, but it doesn't matter. We're going to follow the same steps and the same process. Check to see what radicals can be reduced. 6 would be 2 times 3. That's not going to reduce any, so I'm just going to leave it 10 root 6. Bring the plus 18 down, and whatever comes out from under this radical is going to multiply to it. So 150, I think right away, 15 and 10. Okay, 15 is 3 times 5. 10 is 2 times 5. I have a pair of 5's right here. Ooh, there they are. So a 5 comes out, but I have a 3 and a 2 that get left behind. 3 times 2. And I have a minus 4 I'm going to bring down, and whatever comes out from under this radical will multiply to it. So 2 times 27 was what I thought. You could have thought something else. That's okay. Let's see, 2 is broken down. 27 is 3 times 9, and 9 is 3 times 3. So I have a pair of 3's, so I know a 3 can come out, and then I still have a 2 and a 3 that are going to go back underneath the radical because they don't have a partner. So let's kind of see what we've got. We got 10 square root 6. So I have 18 times 5. Let's see what that is. 18 times 5 is 90. That's positive 90 square root 6. And then we have negative 4 times 3, which is negative 12 square root 6. So we know we got a square root 6 on here because we have square root 6, square root 6, square root 6. So I have 10 plus 90 minus 12 is 88 square root 6. Whew. All right, one more. Let's try this application problem down here. You know you were looking at it thinking, I don't want to do that. So let's try it. I want to find the perimeter of this triangle. Remember, perimeter is adding up all of the sides. Okay, so we have 2 square root 72 plus 8 square root 18 plus 16 square root 2. Okay, so let's break down and see what we can break down. I start off with a 2, so anything coming out has to multiply to that. 72 is 9 times 8. Okay. 9 is 3 times 3. And 8, here's my trick for 8. 8 is 2 times 2 times 2. It's just kind of a time saver here. So let's go. I got a pair of 3's, so a 3 is going to come out. I've got a pair of 2's, so a 2 is going to come out. and then I have a 2 left over. So a square root of 2 gets left behind. Okay, now we have a positive 8. Anything that comes out from under here will go to the positive 8. So I would say that's 2 times 9, which is 3 times 3. So I have a pair of 3's right there, and then this 2 has to go back under the radical. Plus 16 times, well, the square root of 2 is not going to break down, so we're just going to leave that as it is, 16 square root of 2. So let's see what we've got. 2 times 3 is 6, times 2 is 12, root 2. 8 times 3 is 24. Then we have the root 2, and then we have 16, root 2. So we know our answer is going to have root 2 on it, because that part's not going to change. So we have 12 plus 24, which is 36. 12 plus 24 is 36, plus 16 more is 52. So we get 52. Root 2 is the perimeter of that rectangle. All right, see you in class.